Hi everybody, this is Mrs. Hennefarth and I am doing a lesson on percent increase and decrease. This lesson is going to get you ready for lesson 14 and 15, which we will do after this. So, the very first thing I'm going to ask you to do is draw the following on that white section of your paper. And you're going to notice that I've got 5 equal squares. These are all equal. And what I'd like you to do is shade in 4 of them, draw an X and the Y. So go ahead and do that. And then what I'd like you to do is jot down some notices and wonders. What do you notice? What do you wonder about this drawing? So hopefully, maybe jotted down some things. These are what I noticed and wondered. I noticed that I've got a diagram that I've got 5 equal blocks. I noticed that 4 are shaded and that they're labeled X. I noticed that 1 is not shaded. I noticed that the whole shape is labeled Y and that 4/5 is shaded. So 4 out of the 5 are shaded. I also am noticing, I think I already indicated that this was Y. And then what did I wonder? Well, over here I jotted down some things about my wonderings. What does the diagram represent? I wonder what all this means. What do the X and Y represent? If the diagram represents a fraction or a percent, which part is the whole? And why are only X and Y, or why are only these shaded? So those are my wonderings. So hopefully you were able to jot down some of those. If you'd like to just add those to your notice and wonderings, that'd be great. I'll go ahead and stop the video for you. So we're going to move on to this next section, which is on visualizing percent change. And I'm going to note or make mention of these 2 diagrams. We have A and B. And I'm going to take a look at A, and I know that it says last year is 100%, and I can see here that this is the 100% right here, and that there's this 25% that were added on. So if I look at just A, I know that if this was last year and this was this year, that there's been an increase, and that increase is shown with that 25%. Moving on to B, you're going to notice here that I again have that 100%, and I'm going to notice that out of this 100%, that this year I could see that this 25%, instead of being added on, is contained within this 100%, which gives me pause to think and know that this is showing a decrease of 25%. So moving on, it says that we are supposed to match each situation. So I have this situation, these A, B, C, and D situations that we're supposed to match. And then what we're supposed to do is, looking at these 2 graphs, A and B, match it, and then explain why you chose that. So I'm going to go ahead and, if you could pause the video, that way you could go ahead and jot down the reasons why you matched each one. So I can see that in A, if I read compared with last year's student population, this year's student population increased 25%. So again, if I look at my 2 graphs, you're going to note that if this is graph A, that here's last year, here's this year, and I see this increase right here of 25%. So I said that it was graph A because it shows 100%, which is last year, and the shaded 25% that was added, this is the 100 right here. Then I can note that this year, which is this right here, which is the 100% from the year before, that I've added 25% onto my diagram. So, moving on, it says this year's student population is 75% of last year. So if I take a look at these 2 diagrams again, I'm going to notice that I have this year and last, and A and B, and it's stating that I'm looking for 25%. I look right here. This year's student population is 75% of last year's. So if this is 100, and I'm going to notice this 25%, well, if I take 100% and I subtract 25%, I know that that's 75%. So graph B shows 100%, and then we know that 25% is shaded. Therefore, if I subtract 100 from 25, I get 75%. Therefore, I know that graph B goes with this second statement. Moving on to the next one, it said compared with last year, this year's student population decreased 25%. Again, in looking at both of these graphs, which one showed that I'm comparing with last year? It's got to be graph B, because if I look here, I've got this 100%, that was last year, and this year it decreased 25%. Well, right there is showing the decreasing of 25%. So again, I'm going to say that it was graph B. As you can see on the last statement states that I've got this year's student population is 125% of last year's. So if I look at these both graphs, well, I know that B relates to decreasing. So if I go back up here to graph A, I'm going to see here's my 100% right here, which is indicated. And this year, which is what it's referencing, is 125% of last year's. So if this represents 100, I'm going to add 25% on. Therefore, graph A is what it matches. So moving on to the second problem, it asked me to draw a diagram to represent these situations. So this diagram that they're asking us to draw is I like to draw what is known as a tape diagram. So it's a rectangle. So I'll just make a reference up here. And it says for me to draw the number of ducks living at the pond increase by 50%. So if I'm going to say that this rectangle represents the number of ducks, and I know that that's 100%, that's my whole. Okay, and if I want to show it increasing by 50, that means I've got to take half of this and add it on right here. So I'm going to do my best to take a look at this. So here's my 50% of an increase. So this is what was added on. Okay, so again, I'm showing that the original number of ducks and that the 50% is more than what I originally have, which means now that this is showing 150%. So I'd like you to go ahead, and I'm going to do the next one. The number of mosquitoes decreased by 50%. I'm sorry, by 20%. So you're going to notice that I've got the number of mosquitoes, and if I state that this is 100%, and I'm looking to take 20% away, so if I divide this up equally, I know that 20 goes into 100, so 100 divided by 20 equals 5. That means I have to divvy or divide up my number of mosquitoes up into 5. 1, 2, 3, 4, 5. And if I take 20 away, 20%, right? 20, 40, 60, 81. If I take 20% away, that means this is showing what it decreased by, which therefore means I have 80%. So 100 minus 20 equals 80. So that means I have 80% of the new number of mosquitoes. So number of mosquitoes decreased. So what do I have now? 80%. So in this next activity, it says 14.2, computing percent change efficiently, efficiently. What we're going to be doing is we're going to be learning or revisiting a way of calculating percentages. And we in middle school learn different ways. We know how to troubleshoot and do guess and check to figure it out. But what we're going to be doing is calculating the percent, and we're going to be looking at Diego's work here, and we're going to see, is there a more efficient way to do it? A lot of times what we've done historically is we take the old amount, and then what we do is multiply by the percent, and then we either have to add or subtract depending on what we're doing. And so what we want to do is try to do it all in one operation. So what I'm going to do is ask you to I'm going to read this problem out loud. It says an article in the paper says that the local high school student population will increase by 10% next year. Diego knows that this year about 1,300 students attend the high school, and he wants to figure out next year's population. So what he does is he drew a diagram, and this is very similar to the diagrams you saw me draw up here, as well as to what you saw on this front page. Again, we're talking about diagrams to represent a whole or parts of a whole. So I want you to go ahead and just take a look at what he's drawn. I want you to look at his work, and I want you to just think about what he's done there. And I want you to just jot down whatever notes or any thoughts that you may have about what he's done so far. So in just taking a look at his work, again, I'm going to note that I've got 100% right here. And I know that that 100% is that 1,300 students, and I get that information right here because he knows that this year he's got 1,300 students in his high school. He knows that the population of the high school is going to increase by 10%. And I noticed that he took this 100, there's that 1,300, and he added on 10%. And then I noticed that he's got this 110 right here. He's got 100, he's got 10, he's got 13. If I look at his work, I'm going to note that he's got 1,300. And I'm wondering, here's 0.10 or 1/10. This is his 10%. And I noticed that he's multiplied this. Then I also know that he took 1,300, and now he's got 1 plus 1/10, which is equating to that 100% plus 10% more. So he has eliminated, and he's calling that simply 1, and that 1/10 is that 10%, which is right here is a decimal. He's added those two together, and then he's multiplied these two amounts, and he gets 1,430. So it said to explain each step in Diego's method and why does it work, and I think I just did that. So hopefully you'll see, or you'll explain, or if you need to stop the video, go back and listen to my explanations again. I'll also take a moment and I'll jot down each notation. So again, just jotting down some of my thoughts. We have the 1,300, which is the original amount, and he's adding 10% of 1,300. So this is where he's actually doing the step-by-step of his work. And then in his next step, he distributes. So what he noticed, or what I want you to notice, is right here I've underlined 1300 and I've underlined 1300. So what he's done is he's factored out, or he distributes out the 1300. In other words, he's basically taking 1300 out from here and 1300 out from here. And when he does that, he pulls it in front. There's the factor of 1300. And what is left when he factors out 1300? In other words, he's divided 1300 by 1300, which is 1. So he's left with 1 plus. And what happens when you, again, factor out the 1300 is you divide 1300 by 1300, again, and what's left? 1/10. So this is how the 1300 stands alone in the front of the parentheses. So after he does that, he adds 1 plus 1/10. And when you add these two together, you get 1.1, or 1 and 1/10. And then he then simply multiplies 1300 by 1 and 1/10, and he gets 1,430. So we just explained each step. So now what we're going to do is we're actually going to practice doing that exact same thing down here. So we're going to notice, and I'll do the first one for you. You're going to notice that I've got a 7 and I have times 7. So these, you got a 7 plus 4/10 times 7. I'm going to notice that I've got a 7 and a 7. So what I'm going to do is I'm going to distribute, or in other words, I'm going to factor out the 7. So in other words, I'm going to pull the 7 in front, and I'm going to put parentheses. And what am I left with when I go 7 divided by 7? I have 1. And I'm going to go plus. And I'm going to pull that 7 divided by 7 again is 1. And what's left over is 4/10. So again, I haven't multiplied 4/10 times 7 and added it to 7. What I did was pulled the 7 out. I factored it, or I distributed it out. And what did I have left over? I'm going to do the second one as well, just to give you a chance to kind of wrap your head around what I'm doing. I'm going to notice that I've got 24, and I've got 24 here. Notice that this is being multiplied. So what I'm going to do is, because these are factors, I've got 24 that I can factor out. So I'm going to pull the 24 out in front, and I'm distributing it out. And what am I left with? 1, because 24 divided by 24 is 1, plus, and again 24 divided by 24 is 1. What am I left with? 8/100. Okay, so what I'd like you to do is try the next two on your own, C and D. I'll pause the video, and that way you can come back and double check. So what I've done is I've gone ahead and I've done the last two. You can see that I factored out the 13, or distributed out the 13, distributed out the 98. And what did I have left when I did that? 1 minus 1/10, and then here I got 1 plus 2/100. And the only other thing I'm going to go back and do is now simplify. So I've got 7 times 1 and 4/10. I have 24 times 1 and 8/100. And I have 13 times 9/10. And the last one is 98 times 1 and 2/100. So again, taking a look, I'm only using multiplication in each one of my final answers. And this is going to become very prevalent as we do percent increases and decreases in our next lesson. Turning the page, now we're on to question number 3. It says the first calculation, so I'm going to go back here. The first calculation gives us 7 increased by 40%. What do the other calculations give as a percent change? So again, if I look here, if this is saying I've got 7 and I'm going to have a 40% increase, I can say right here that I have 24 is being increased by 8%. I can say 13 is being decreased by 10%. And I can say that 98 is being increased by 2%. So again, I'll go up here, and actually I'm just going to do it right on here because I've got everything written, that this is showing, and I'm going to show increase as an arrow pointing up. So we have, this is being increased by 40%. 24 is being increased by 8%. I have 13 being decreased by 10%. You're probably asking, where did I get the 10%? Well, if I take 100 and I subtract 1/10, that's 90% remaining, but what did I take away? I got 10% decrease. And back right here, I've got 98 was being increased by 2%. Okay, so moving on, we just did question number 3. Now we're going to go in and we are supposed to write an equivalent expression. Again, this looks very similar, and I'm going to be using the distributive property. So again, we get more practice rewriting to get familiar with what we're going to be doing in lesson 14 and 15. So what I'd like you to do is I'm going to go ahead and pause the video. I'd like you to try these on your own. See if you can rewrite them based on what I did earlier, rewriting an expression using multiplication. Try 14-3 on your own. So you can see in rewriting expressions here that what I did, again, was I distributed, or I factored out the 65. So I got 1 minus 0.45, which therefore means I need to still simplify this, which is 65 times 0.55. And again, using a calculator, please. Don't feel that you need to do it in your head. The next one is, I notice I have 65. And I can factor it out or distribute out, which leaves me with 65 and 1 plus 45 hundredths. And then I go ahead and simplify this to 65 and 1.45. This one was a little tricky. I was hoping that you would get that. So what I did was, you're working backwards. This is the final result. So if I think about what was I doing up here, I had two numbers that I had 65 and 65. So the same thing, 91. So how can I write 1.2? Well, I can take 91 and I can write or rewrite 1 and 2/10 as 1 plus 2/10. And then if you distribute, so 91 times 1 is 91. 91 times 2/10 is 91 times 2/10. And that's simply what you get as a equivalent expression working backwards. And the last one is very similar to what we've done in A and B. So again, noticing that I've got an X and an X, I factor that out or I distribute it out. And what do I have is I've got 1 plus 4 hundredths. And I add these two together and I get X times 1 and 4 hundredths. So moving on, it says now we're going to evaluate by multiplying just two numbers in our calculator. And I want you to write down the expressions that you calculated. So again, I want you to take a look at this. This saying that 130 is being increased by 10%. Okay, so increased. So again, if I draw that tape diagram, so it's being, so I start with 100, and I'm increasing by 10% more. So this is 1. And I'm adding 10%. So what do I end up with? That if I take 130 times 1.1. Okay, so now if I look to the next one, and so this is what I'm evaluating. What is this? And again, I'm going to use a calculator. So if I've got 130 that's being increased by 10%, that means I'm going to end up with more than 130. So again, using a calculator, 130 times 1.1 is equal to 143. Okay, so what I want you to do is try B, C, and D on your own, noting that we've got decreased. So again, if I draw a tape diagram here, and if I know that this is 100, and I'm decreasing that by 30%, that means I'm going to take 30% away. What is left, if I know that this is 0.3, what's left, 0.7, maybe that'll gauge you or put you in the right direction. Same thing here, more than, so 50% more than, again, thinking about this as being the whole, 6% less than. So again, I'm going to have a bigger number. I'm going to have a number that's going to be smaller. So go ahead and do these on your own. Give it a shot. Use a calculator. Okay, so taking a look at my work here, you're going to see that I've got 130 increased by 10%. Again, I'm showing that 100 or that 1 plus 10. I'm going to multiply it by 1.1, which is equivalent or equal to 143. And again, I know that 130 is definitely going to be bigger because I'm increasing it. When I have decrease, I know it's going to be below. So again, thinking of this as being 100%, and what do I know that I'm decreasing it by 30? So what am I left with if I have 100 times 30%? Well, 30% is 0.30. So what am I left with? I'm left with 0.7. So I'm going to multiply 25 times 0.7. And what do I have when I multiply 25 times 0.7? I have 17.5. Moving on, I have 50% more than 38. Again, my 38 is the whole. That's the big, what I've got. And what am I doing? I'm adding on 50%, which means I've got 1.5. Again, 50% can be written as 0.50. So when I add 1 plus 0.50, I get 1.5. So when I multiply 1.5 times 38, I get 57. And again, the reasoning stands behind that it's going to be more than 38. Moving on, I have 6% less than 200, so I know it's going to be less than 200. How much less? 6% less. So again, I'm trying to do this. Again, going back, I'm just using two numbers in my calculator. So what did I do? Here's my whole. Here's my 6% less. You need to remember that 6% is 0.06. So if I take 1 and I subtract 0.06, I get 0.94. Going over here, 200 times 0.94 is equal to 188. All right, we're in the home stretch. We're on the last page. And what do I have on the last page? I've got write an equivalent expression, again, that uses only multiplication. So now I want you to go back and thinking about factoring out or distributing out the variables that you're seeing here. Okay, so again, go ahead, shut the video or pause it. Go back, give it a shot. See what you... So again, if I look at my final answers, we have got P times 6500ths, Z times 1500ths, Q times 1 600ths, and R times 1.64 or 1 6400ths. So what I did here was I showed you the math behind and what my final answers were. One of the things I want to just note that again, this has all been done out of context, meaning we haven't seen anything relating to a problem other than simply procedural math on how we're going to dive into lesson 14 on percent increase and decrease. And this will hopefully make a little bit more sense as we move forward through our next lesson. Thanks for watching.